changing the reaction rate of an foaming reaction, and here are my materials that are being used. First, we're going to prepare the catalyst by adding the yeast to the about 100 ml of water, and then we're going to stir it until the yeast dissolves in the water. Then we're going to prepare the reaction solution. In a cup, we're going to mix half a teaspoon of the detergent, this one, with 2 tablespoons of the hydrogen peroxide. And then we're gonna stir gently, but be careful to not create much foam. Next, we're going to add 1 ml of the hydrogen peroxide and detergent solution to each of our test tubes right here. We're going to set a timer for 2 minutes, and then we're going to add half a milliliter of the yeast solution to each of the 3 test tubes. And then we're going to swirl them gently and start the timer for 2 minutes. After 2 minutes have passed, we're going to measure the foam height from the bottom to where the foam rises for each of the test tubes. Next, we're going to repeat the process, but we're going to create a new reaction solution with half a teaspoon of the detergent with only 1 tablespoon of the 3% hydrogen peroxide. Then we're going to stir it, and 1 tablespoon of tap water. Now we're going to add 1 ml of the new hydrogen peroxide solution to each test tube and half ml of the yeast solution. After 2 minutes have passed, we're going to measure the height of the foam again. This is the why do apples and bananas turn brown with the apple experiment. So first I have to cut the apple, and then I need 2 apple slices, for which one will be the poked and the next one will be the controlled, and this one I have to poke it several times. Then I have 4 plates, each one labeled milk, vinegar, water, and lemon juice. I'm gonna add to them each respective liquid, and then I'm gonna poke them and observe them after 30 minutes. I'm gonna add the milk. I'm going to add vinegar to this one. I'm going to add water, this one. Then I'm going to add lemon juice to this one. And then I'm gonna poke it. one of them. And the control one too. So after 30 minutes, the one in the milk still turned brown. The one with the vinegar didn't turn brown that much. The one with the water turned brown. And the one with the lemon juice didn't turn that much brown. And the control one looks like this after 30 minutes. We're going to put the bottom piece of the banana into boiling water as per the instructions for 30 seconds. So we're gonna start now. So we can see now that the bottom part of the banana remained browned, the part we boiled it. Other part, we're gonna use a second banana and we're gonna observe it over the time of a week because we're gonna be putting it in the fridge. Day 2. The banana looks more brown on the skin, so we're gonna keep on observing it. This is day 3 of the banana. The banana looks even more brown. We'll continue the progress over 4 more days. It's day 4 of the banana. The skin looks even more brown and the texture feels sort of soft. It's day 5 of observing the banana. The skin looks really brown, the texture is really soft, so we're going to observe it for 2 more days. Day 6, the banana is really brown and the texture is really soft. So tomorrow is the final day we're gonna be observing the banana. Today is the last day of checking the banana in the fridge for a week. The skin is very brown and the texture is really soft, as you can see. This is the enzyme lab and I'm about to perform the one with the pineapple, and these are my materials over here. I'm going to proceed to cutting the pineapple. Next is cutting up the pineapple and blending it into the blender. After cutting the pineapple into smaller pieces, we are going to blend it. Next we're going to place the blended fruit into this cheesecloth and then we're going to squeeze the juice into this container. Now that I have the juice squeezed out, I will put half of it in another container. Then we're gonna microwave one of the containers until the juice inside is boiling. Next I labeled the heated one heated and the unheated juice unheated after putting the heated one in the microwave. Next I labeled 3 cups milk, milk plus juice and milk plus heated juice. Next I'm going to add 1 tablespoon of milk to each cup. Next I'm going to add 1 teaspoon of the fresh unheated pineapple juice into the milk plus juice cup. And this is a half a teaspoon measuring spoon, so I'm going to add 2 of them. After 5 minutes of stirring and observing, the milk looks like this. Next I'm going to add 1 teaspoon of the heated juice to the milk and heated juice cup. And I'm going to stir it and observe it for 5 minutes. After 5 minutes, the milk with the heated juice looks like this. Comparing it, the milk cup is clear. The milk plus the juice, the unheated juice, looks like it curdled the milk somehow. And the milk plus the heated juice doesn't look the same as this one.
The lab 1 video, we found that the foam height changed because we changed the concentration of hydrogen peroxide in the solution. And this is because hydrogen peroxide decomposes and breaks down into water and oxygen by the addition of yeast that contain the catalyst enzyme. And this works as a catalyst that makes the reaction go faster by altering the concentration of hydrogen peroxide, which makes the height of the foam decrease. Because molecules start to collide, foam is created as a result of oxygen that is released from or broken down from hydrogen peroxide being trapped in the detergent bubbles, and this is the proxy for a reaction. We can find a hydrogen peroxide concentration that results in these numbers because we can alter the concentration of hydrogen peroxide or yeast. And it is important to regulate the rate of chemical reaction because we can find out how fast products are made and what causes the reaction to slow down or how we can improve these reactions. We graph the results over here. Foam height x-axis, hydrogen peroxide y-axis. You can see that the one that had the 2 tablespoons concentration of hydrogen peroxide had a higher foam height compared to the lower concentration hydrogen peroxide, and with the one with the low yeast and different concentrations related to the experiment we did in the video and with the different tubes. And we got the data from here, from the table, our different heights and our height, average height. So when we change the concentration of the yeast solution, the foam also decreases. In the second video, we can prevent apple slices by turning brown by adding different substances that prevents the apple from oxidizing due to contact in the oxygen, because the tissue in the fruit is what causes oxidation because the enzyme called polyphenol oxidase triggers in the apple, and we can avoid this by lowering the pH or making the apple more acidic. So we observed our samples, and I mentioned it in the video, but this is because when we added vinegar and lemon juice, it didn't go brown at all due to the acidity, so no oxidation. And milk and water didn't have any acidity, so it kind of turned brown, just like the pulped one. And in the banana, we saw that for 30 seconds in boiling the bottom part, it turned brown because it reacts with oxygen and forms melanin in the skin. And we saw what happened to the banana in the fridge over a week. In the last video, when the enzyme bromelain in pineapple juice is heated, the enzyme is broken down by heat denaturation, and we observe the different results. The milk with the fresh juice got curdled due to the bromelain enzyme being the bromelain enzyme effect on the milk, and the one that we heated undergo no changes because we're gonna explain that in a while. And we compare the 3 cups. The one with milk looked smooth and creamy. The one with juice looked milk curdled, and the heated juice with the milk remained unchanged. This is because heated pineapple juice doesn't curdle milk because once heated, the enzyme is deactivated or destroyed, and this doesn't curdle the milk. And the last question is, if an enzyme wouldn't work properly in our body, we would most likely die or wouldn't exist because enzymes are too important. They're what cause our chemical reactions to go fast, and if they don't, it'll be rough for us because they're key catalysts which drives the reactions. And that's it for this lab.